Joe Newton online class. In this class, I want you to solve this calculation in physics. And that question is taken from a topic in physics known as measurement of heat energy. Of course, we know that heat energy is one of the forms of energy known as thermal energy. Meanwhile, it concerns specifically, that is, the concept of heat capacity and the specific heat capacity. Now, let us remind ourselves, what do we mean by heat capacity of a substance? The heat capacity of a substance simply means the quantity of heat energy required to raise the temperature of that substance by 1 Kelvin or 1 degree Celsius. Then, by specific heat capacity of a substance or a body, we mean the quantity of heat energy required to raise the unit mass, that is a unit mass, that is 1 kilogram mass of that substance by 1 Kelvin or by what? 1 degree Celsius. That is it. That is per degree Celsius or per Kelvin. Okay, now let us look at the question on the board quickly and tackle it. The question says, what is the quantity of heat required to raise the temperature of 500 grams of copper from 20 degrees Celsius to 80 degrees Celsius? Then we are given in bracket that the specific capacity of copper is equal to 400 joule per kilogram per Kelvin. Now, in solution, we now see from the information given that the mass of the copper is equal to 500 grams. Then, are we to solve with this 500 grams? No, because it is not in the standard unit of mass. The standard unit of mass is kilogram. So we are bound to convert this 500 grams to kilogram. Even if you look at the unit given here, it is in joule per kilogram per Kelvin. That shows us that we must convert this. And even that it is in joule per gram per Kelvin, then we would have solved with this gram. So in this condition now, converting this to kilogram, we divide by 1000 because 1000 grams make 1 kilogram. So it will be equal to 500 over 1000. And that will give us, and the final temperature of the copper is 80 degrees Celsius, that is theta 2. Then, which implies that the temperature change, that the rise in temperature during the experiment or during the heating of that copper is, that is delta theta, is equal to theta 2 minus theta 1, which is 80 degrees Celsius minus 20 degrees Celsius. And that will give us 60 degrees Celsius. So this is the temperature rise in that experiment. That's our delta theta. Okay, then we are given that the specific capacity of that copper is 400 joule per kilogram per Kelvin. We call it small c, which is the conventional symbol we use, is equal to 400 joule per kilogram per Kelvin. Then, now for us to find the quantity of heat energy required to raise that temperature of that copper from that 20 to 80 degrees Celsius, it will now be H. We can use H or Q as the case may be. These are the symbols or the letters we use to represent the quantity of heat energy. H is equal to mc delta theta. So the quantity of heat energy required to make that heating, raising that temperature, is mass times specific capacity of that copper times temperature change or the rise in temperature, which is equal to, our mass is 0.5, remember, 0.5 times the specific capacity given to us is 400 times the change in temperature is 60. So that will give us, quickly, 0.5 is like 1 over 2. So you can call it 1 over 2 times 400 times 60 for easy work with our calculator. So 2 cancel itself here, 1. 2 divide 400 gives us 200. Then we are left with, we are now left with 200 times 60. 2 times 6 is 12, which is 1, 2, we put the 3 zeros, 0, 0, 0. So this is what we have. Remember, the unit of heat is what? Unit of energy is what? Joules. So the quantity of heat energy required is 12,000 joules. Or in other words, So our H is equal to 12,000 joules, or you can change it to kilojoule. Remember that 1,000 joule make 1 kilojoule because kilo is quantity in thousands. So when you divide this by 1,000, give you 12 kilojoules. That's so 12,000 joules or 12 kilojoules. So thank you so much for paying attention to this particular class. I hope you enjoyed it and you have now understood how to tackle or calculate the quantity of heat energy required in raising temperature of bodies or substances as involved heat capacity and specific capacity in terms of heat energy measurement. For more of these solutions in physics and mathematics, visit my YouTube channel at Joe Newton Online Class. Also follow me on Facebook, my Facebook page, even TikTok and Instagram, the same Joe Newton Online Class, to enjoy physics and mathematics tutorials with me. When you go, you subscribe for notifications, like and share.